Okay, in order for us to understand more on the calculation of buoyancy, we will do two examples. The first one, a block is floating in water as shown in figure 1. Determine the height of the block submerged in water if the height of the block extended out of the surface is 0.2 meter. So what they are trying to ask us is for this HD over here. Alright, H displacement. Okay, the density of the block is 780 kg per meter cube, while the density of water is 1000 kg per meter cube. So we can see from this equation, this question, the density of the block is lower than the density of the water. It means the density of the block is lower than density of water. It means that the block will be floating, as the picture shows us right now. So 0.2 meter part of the block is outside of the surface of the liquid, and assuming this is the surface, so the length of the block is 1 meter. If you can draw it to the back like this, the length is equal to 1 meter, and the width of the block is 0.5 meter. So the width of the block is 0.5 meter. Okay, so I've done the answer scheme for this question. So the first part is just the equation FB equals to W. We don't have any external force, so we will continue to use that equation. So as we already know from previous slides, so this is what going to happen to the equation. The G and the A will be the same because from the picture that we have, the surface at the top and the bottom should be the same. Okay, if you continue further with this, the HD is equal to the density of the object multiplied by the height of the object and divided by the density of the fluid. Density of the object is 780, density of the fluid is 1000, but if you can see from here, HO is equal to 0.2 plus HD. How do we find this number? We find it from this picture over here. HO is the total height from the top of the block to the bottom of the block. So the total height should be 0.2 plus the HD that we have down here. So this is the reason why the equation here is 0.2 plus HD. If you continue with the calculation, you will get the answer for HD to be 0.7091 meter. And if you are finding HO, it will be just 0.7091 meter. This is the HD plus the 0.2 meter. So you will get HO to be 0.9091 meter. Okay, pretty simple, right? So second example, 2 cubic blocks, oak and steel with the same dimension, 0.5 times 0.5 times 0.5 meter, are dropped into an oil tank as shown in figure 2. Determine the amount of external force required to hold each block suspended in the fluid and the direction of each external force. For this question, we have an external force, and the external force will be included in the calculation. So what we can understand from this example is the oak block, density of oak is lower than density of oil. It means if this block is dropped into the oil tank, the block will be floating. For steel block, the density of steel is much higher than the density of oil. Means if you drop it, the initial condition will be the steel block is sinking to the floor of the tank. So what does it mean by this second wordings are determine the amount of external force required to hold each block suspended? It means that what is the external force required to push this block so that the block will stay suspended like this for oak block. For steel block, how much force is required to pull it up in order for it to be suspended like this? Okay, to continue answering question 2, for example question 2, I will draw it in a different slide. Okay, assuming this is the oak block and it is fully suspended because of the external force acting towards it. The weight of the block will move downwards and the force of buoyancy will act upward. And the study for this particular subchapter, which is buoyancy, will only focus on vertical forces. So we can do summation of Fy equals to 0, and negative Fe minus W plus Fb equals to 0, and your Fe is equal to negative W plus Fb. Right, so from there your Fe is equal to negative rho hook, okay, times G times V hook plus rho oil times G times V oil. Okay, you can see that from the picture that the height of the object should be the same as the height of the displacement, because for this particular question the body of the object is fully submerged. So when fully submerged, the HO should be the same as HD. Because of that, the volume for oil and oak should be the same as well. So when we factorize it, it will become G times V, which is the same V over here. Okay, and then we multiply density of the oak plus the density of oil. Getting the numbers inside the equation, 9.81 multiplied by 0.5 cube minus rho oak, which is 700 kilogram per meter cube, plus rho oil 850 meter cube. So your Fe should equal to 183.94 Newton, and the force is downward. Okay, this is for oak. Sorry to put it here. Okay, so I'll use a different color so you will not get confused. On the right side, we will study for the steel block. The steel block, in order for it to be suspended, remember, we need a force acting towards it upward, which is external force like this. So the weight will be downward and the Fb will be upward. So if you do summation of Fy, it will be different from the oak block, because the oak block, the force is downward, and for the steel block, the external force is upward. It should be equal to 0, and it will be Fe minus W plus Fb equals to 0. So your Fe is equal to W minus Fb. See, there is a difference between this equation and this equation. So it is not the same, depending on the picture and depending on the external force direction. If we do, we continue with the calculation, it will equal to rho steel G V steel minus rho oil G V oil. Once again, as I said before, the HO and the HD should be the same. So these two volumes should be the same. If we factorize it, GV will get rho steel minus rho oil. It will become 9.81 multiplied by 0.5 cube multiplied by 8050 minus 850. So the answer for external force will be 883 to 9 Newton, and the direction of the force is upward. Okay, I believe these two examples will help you to understand a condition where you have the example 1 to be only using equation FB equals to W, no external force, while example 2 requires you to add an external force over there, but only just an addition of another force, and we can do the summation of force in the y direction to solve the question. That's all for today. Thank you.